In this exam item, we've got a 3-hinge arch. That's one of these manufactured steel frame systems. Pin supports at the base and a hinge up at the crown joint, and the members are tapered, thick at the beam column joint. And we've got a wind loading case, right? Wind moving from left to right. We've got a pressure on that left side, we've got suction on the right side and on the leeward side of things. And along with this, we have then a deflected shape that goes along here. And before I even kind of think too much what's going on here, I note I got compression on the left side of that column, tension on the other side, same thing on the BC beam, but on the other one it reverses, and likewise over there it reverses as well. Right, so that might be good to just take note of. We don't know what our task is yet. We're given 4 funny little shapes here. These are representing the moment diagrams. Select the set that is most consistent with the model and deflected shape, right? And these are drawn on the compression side, which just means that the moment diagram ought to show up where we see all of these C's. And so this is kind of interesting here. We have pin supports, and note that 2 of these have non-zero moment at that pin support. So C and D cannot be correct. Doesn't even matter what else is going on in the system, due to non-zero moment at the support. Right, now here's another little key. There is a hinge at C. That means the internal moment has to be 0. Well, that has 0 moment, that has 0 moment. Oh wow, those don't either. This was alone to say that C and D are not correct, but also not zero. You have a non-zero moment at the hinge. So there's 2 things that are wrong with C and D. And then we come back and we say, well, this looks like a pretty complicated loading situation, but note here we've got uniform load, uniform load, uniform load, uniform load. That means with uniform load that the moment is going to be a function of x squared. It's going to be a parabola. It's not going to be a straight line, all due that W is constant in the member. Right? And so when we look at that, we see that that's not true for A. That in A, what we have is that we have a linearly varying moment, and that means no distributed load, or you could say W equals 0. And that's not the case. So we know A can't be it either. Right? And indeed, the only one that works at all then is B, because that's the one that has 0 moment at the supports and at the hinge. We have second, well, we don't know that that's really drawn second order, but at least it's curvilinear. That's important. So this is at least looks like a function of x squared. The other ones are not. That's another reason to rule out C. And we've got then curvature that matches, right? That would be curvature like that, and curvature like that, and that's exactly the deflected shape that we've got down here. That was created by a computer model of that you see over here. That's a direct result of that. So the answer has got to be B.